Transformers, Transformers, Transformers. Today you're going to learn how to have a little bit of fun with a little bit of this. So to get started, you're going to need a microwave oven transformer. These are common, they're used all the time for stuff. You can get them anywhere. Junk, old unwanted microwaves, you can just scrap them from for free. And you're going to need an old extension cord. You can even use one. You can even use a cord that came from the microwave. And there's basically on any transformer you got a primary coil and a secondary coil. So the primary coil is where your 120 goes in. So your 120 goes in here, and this has a thicker wire, and then you get your high voltage on the secondary, which is thinner wire, which has more turns. And so it's the ratio between the primary and the secondary coil. That's what gives you. You take the ratio between those two, and that's what gives you the multiplication factor of your input and your output voltage. So because there's such a difference in this, it's like I don't know what the ratio is, but it's about, I don't know, probably 15 to 1 or something. Anyways, you get 120 here, and you get about 2100 volts coming out of this coil. So you wire this up to just mains 120 here, and then on this side of the transformer, you'll notice right here, one end of this high voltage coil is riveted to the transformer core itself. So the one end of the secondary is actually the whole transformer core. And then these two, don't worry about, you can cut that off, that doesn't matter. This is the output terminal, the other output terminal for the secondary. So you're going to want one terminal connected to a chicken stick. You can make this out of pipe. I don't really suggest wood, usually plastic. I would use plastic, and then just a nail and some wire, that's all you need. And then alligator clip helps. So basically, because these are coated, the cores are coated for rust protection and dielectric properties, we are going to file this off here. I already did that. You just take a file or even a light or burn it off, doesn't matter. There you go, and then you connect that to your core, and then connect the other end to your alligator clip. And now you basically have 2000 volts whenever you want. It's that simple. I'll quickly show you this here, and I'll show you why you shouldn't do it this way particularly. Now, a lot of people, before I get that thing going, a lot of people probably won't have one of these. This is it's just a little variac I have. So it's just, it's a variable inductor, basically. There's only one core in this, but it just allows me to, it's kind of like a rheostat. Works way different, but just gives me a variable output voltage into this guy here. That's the only thing. I just use it for, well, safety and control, basically. So now that we got this all set up, let's get this thing going, I guess. Here we go. Contact. And as you can see, this is, I don't know, somewhere 30 volts. I'll zoom in a bit for you guys. So this right here, I shut it off, don't worry. Anyways, this right here, I'll turn it on, and that is, it's about 30 volts is. And as you can already see, we're getting some good sparks. Turn up more. And if you notice, we're getting a little arc already. See that? That's one right there. That's no good. You don't want that. That arc there is being affected by the magnetic field of this transformer core. Because transformers rely on magnetic fields to operate, it screws with the plasma. Screws with the plasma because I believe it's called magnetoplasma something like that. It's basically plasma is affected by magnetic fields, so you don't really want to do this right here because they can flash to the windings, and then you get a shorter sum. So typically you can even take a screw or something, anything really, just as long as you can get the arc further away from the transformer, away from the magnetic fields. So I'll quickly go get something hooked up here and we'll be right back. Perfect, so we're back. Got this guy hooked up here. Let's try this again. Give you more impressive display here. This is about 60 volts here. Notice, much stabler arc. Much better. Let's turn up some more. This is about 120 here. Here, I'll shut this thing off. And you don't ever have to worry about, it's like something, besides it's hot, you don't ever have to worry about some kind of charge being left in here after you shut it off. I'll give you some side angle shots here so you can tell how long this arc is. Alright, so we're back here with a side shot. Something like 40 volts here. There's about 60. I'll zoom out here for you guys. That's about 80. And this is 120. And let's try 140 here. Big, as you can see, big arcs. So now the important part, you mucking around with these, you think it's going to be a good idea, but a word of warning, these can and will kill you if you don't know what you're doing. So number one rule I have is always, whenever you're going to touch one of these, change the wiring, whatever, always have a physical cable disconnect in your primary. I don't care if you have a switch or a breaker, doesn't matter. Those things can fail and you can still die with those. So just a physical disconnect guarantees you that that's not going to happen. That's one of my rules. Another one is in terms of the actual grounding of this thing. I know a lot of people say, oh yeah, you should ground the transformer core when you're using it to make it safer. Well, that's really not the case, because as I mentioned earlier, the secondary high voltage winding is riveted to the core of the transformer. So when you go to ground this thing, you're grounding the core and the secondary coil right here. So what that does is the secondary has reference to ground on the one end. So when you are mucking around with this and you accidentally touch the one wire, it's going to go through you and into the ground, which is, it's not going to feel very nice. You're not going to die probably, but not going to feel very good. So I just recommend just to leave this as is, just have your 120 hot neutral here, and you're good to go. Because if you don't ground it, the core, this is separated from mains, it's isolated. There's no physical connection, so there's no way it'll ever go through you to ground, because it's not referenced to ground. So there's that. So I think it's way better. You'll still get probably a little bit shocked if you touch this, even if it's floating, because there's a capacitance factor in humans where if you touch this, you'll feel a little tingle. It's not going to do anything though. So there's that. There's these. This is another important thing. The shunts on these transformers, most, if not all, of these have current limiting shunts. They're right there and there, right in between the primary and the secondary coils. So these shunts are put in to limit the current draw for the transformer when it's running. But I mean, if you want thicker, longer arcs, you can take those out. You'll heat the transformer up more. You'll melting your wires quicker, but it's a lot more fun. Just be wary whenever you're running one of these without these shunts and you don't have a ballast. I can talk about that later in another video. This thing can pull, I mean, especially the bigger ones, they'll pull 30, 40, 50 amps, which is crazy. So you definitely want to make sure you know what kind of current you're going to need, you're going to be pulling here if you're going to do that. Other than that, these things are pretty good introduction to high voltage world. For any beginner out there, I'll show you how to pull one of these out from a microwave in another video, and yeah, thanks for watching.